All right. So in this section, we are going to be talking about elements and how these elements change into compounds. First of all, what is an element? An element is a material that is made up of only one kind of atoms. For example, pure gold is an example as it is made up of only gold atoms. Okay. So an atom is a fundamental unit of an element. So it's a basic unit of an element. So an element, for example, a piece of iron bar that you see is fundamentally built from atoms. So atoms are the ones that, just like you have bricks that build up a house, you have atoms that build up all the structures that you see. So an iron bar is fundamentally built by so many iron atoms. Okay. So the term element is used when referring to microscopic quantities. So when you have very small particles, when we are referring to very microscopic means they are very small. That term element is used when we are referring to quantities that are really small. And the term atom is used when we are discussing submicroscopic, which means even smaller, because with a microscope, you can actually be able to see microscopic quantities. So no matter how small it is, under a microscope, at least they will be visible. But with submicroscopic, it is quite difficult to see it through a simple microscope. You have to have a very powerful microscope, such as an electron microscope, to be able to see submicroscopic particles. Now, if you need a periodic table, just let me know and I'll print one for you. Right? We've looked at a periodic table all around the class. You'll find a periodic table. And this periodic table, what they do is that it arranges elements in order of increasing atomic number. This is a concept we've seen before. And so looking at the elemental formula used to show the proportion by which atoms combine to form an element. So for example, oxygen, uh, the name oxygen and the formula is O2 because the element oxygen is always made up of two atoms of oxygen. So this number you see down here is called a subscript. So the subscript tells you the number of oxygen atoms that actually combine to form the element oxygen. Okay. And so we have ozone. Ozone is made up of three oxygen atoms. That's why you see the formula for ozone is O3. And then sulfur is S8 because these are all symbols for those respective atoms, right? An atom of sulfur is represented by the symbol S. And so in order to form the element sulfur, you have eight sulfur atoms that come together. And then for gold, one atom of gold is enough to form the element uh, gold. Okay. So now let's talk about compounds, right? What are compounds? Compounds is just a substance that consists of atoms of different elements, okay? So if you go back to the previous slide, you will realize that these are atoms of the same elements that combine to form that element, okay? But in a compound, we have a substance consisting of atoms of different elements. For example, if you look at the salt that we use in cooking at home, it is called sodium chloride. And so it is made up of sodium and chlorine. These are atoms that are different. As you can see, they are represented by this diagram, right? So you will realize that these are atoms of sodium, while the green ones are atoms of chlorine. So they are different atoms that come together, and that is what we call compounds. We can take another example like ammonia. Ammonia is a compound that is used in refrigerators in order to keep the refrigerator or to give the refrigerator the ability to cool substances. So ammonia in there, what happened is that this ammonia is made up of hydrogen and nitrogen. Okay, so when different elements combine, they form a compound, right? When different elements combine in a chemical reaction, they form a compound. So a compound, right, have properties that are uniquely different from elements from which they are made. For example, sodium chloride we use in cooking is made up of the metal sodium and the non-metal chlorine. If you look at the metal sodium and the non-metal chlorine, you realize that they have physical and chemical properties that are different from the sodium chloride itself. Okay. All right. So if we look at this is sodium right here. This is a piece of sodium and this chlorine gas. So you realize that uh, chlorine is a gas while sodium is a metal, and they look different. But whenever they react to form sodium chloride, you will see that the sodium chloride itself is made up of white crystals that are different from this piece of metal and also different from the chlorine gas that you see. That's the power of chemical reactions. Chemical reactions have the ability to produce compounds that are fundamentally different in appearance, in chemical properties, and in all other aspects from the original constituent or elements or atoms that combine to form it. Okay. So when we use a chemical formula, right, to show the proportion by which elements combine to form a compound. So a chemical formula is used to show how many of each atom combine with how many of the other atom. For example, I will take the example of sodium chloride, which is a salt that we use at home. The formula is NaCl. If you look at after the Na, there is no number. Those numbers are called subscript, right? So after each symbol, when there is no subscript, it means that there is an invisible one. So what that means is there is one atom of sodium in this compound and one atom of chlorine. Now, pause this video and think about it for a second. How many of each atom do we have in this formula? So if you think about it, there is no subscript after nitrogen. So nitrogen, there's only one atom of nitrogen, right? And there are three atoms of hydrogen. So the formula for this compound called ammonia is NH3. And then for water, it is H2O. So there are two atoms of hydrogen, one atom of oxygen. Okay. Now, let's look at how we can name these compounds because it's important for us to learn how to name them. Okay, how do these names have been given you? How do these names come about? So one of the first guidelines you want to follow is that each time we are naming this compound, we start with the element farthest to the left in the periodic table. So if you look at your periodic table, you will see that there's a left side and there's a right side on the periodic table. So if you have a compound with two elements, you always want to write the name of the element that's to the left of the other one. Okay. So you want to make sure you locate these two elements on the periodic table and you determine which one is to the left of which. And that one is going to come first when you're writing the name. Now, the second guideline is for the element to the right, you need to add a suffix that we call IDE, right? IDE is going to be added to the name of the element to the right, okay? And we're going to see how this apply. For example, sodium and chlorine. So sodium, if you look at them on a periodic table, sodium is right here and chlorine is right there. So sodium is to the left, and so the name sodium, right, is going to come first, right? Is going to come first. And then this element, instead of you writing chlorine, you will get rid of the INE at the end of chlorine and you replace it with IDE. And so the name is going to be sodium chloride. Okay. So sodium chloride is going to be the name of this compound right here. All right. So for guideline number 2, with different possible combinations of elements, we need to use prefixes to remove ambiguity or confusion. So what does that mean? It means that when we are naming compounds, right, that have more than two atoms, we use these prefixes to indicate the number of atoms. For example, mono means one, Di means two. Tri means three. Tetra means four. And let's see how we can use this. For example, this compound is made up of carbon and oxygen, one carbon and one oxygen. Okay, so we are going to call this compound carbon monoxide. Okay, now look at this other compound here. It's still made up of carbon and oxygen, but this time around there's one carbon and there are two oxygen, so we'll call it carbon dioxide. So the di means two, remember, and the mono means one. So there's no confusion when we use these prefixes because it tells us exactly how many of each type of atoms we have. Again, carbon monoxide, carbon dioxide. Another example here, there are two hydrogen atoms, and so we say dihydrogen monoxide. Mono means one oxygen, di means two hydrogen. Okay, how about this one? Two hydrogen, two oxygen, so we'll call it dihydrogen dioxide. Okay, will you drink this just for fun? All right. So in as much as we have these names that are called the IUPAC chemical names, we also have what we call common names. For example, this compound is called dihydrogen monoxide, but if you use common names, it is more simplistic, for especially in cases where a substance is popularly known with its common name. For example, water is a chemical substance, but is popularly known as water instead of dihydrogen monoxide. So if you go to a store to carry water and you tell them that you want dihydrogen monoxide, they probably will not understand what you're talking about except they did some chemistry. Okay, but if you tell them that you need water, yes, obviously they will know what you're talking about. This compound is called dihydrogen dioxide, but is popularly known as hydrogen peroxide. So substances, their common names are acceptable. Okay, so take note of that. All right. So don't forget the guidelines, okay? Start with the element farthest to the left in the periodic table. For the element to the right, add the suffix IDE, right? With different possible combination of elements, use prefixes to remove ambiguity, and then common names are sometimes used instead, okay? So now let's check for understanding here. What is the name of the compound with the formula CBr? Okay, so there's just one carbon. So usually when the first element is one, we don't have to indicate mono, but you can if you want. You can say monocarbon, that's fine. Or you can just say carbon. So if I say carbon, how many bromine do I have? Four. So I'll get rid of the INE at the end of bromine and I replace it with IDE as we said. And so because there are four, we'll say carbon tetrabromide. Okay. All right. So that's that for this section. I hope you were able to learn how to name these compounds and how you've understood how elements turn into compounds. I'll see you in the next chapter.